So in this problem, we're asked to find the dynamics of a bucket in a well. In the previous example, 9.8, we were asked to do a conservation of energy analysis of the system, and that only gave us the speed of the bucket and the winch and certain points of the motion. Now, in this problem, we can use Newton's second law for rotation to find the acceleration of the bucket, mass m. So in this case, we'll only be solving for a variable, and the angular acceleration of the winch cylinder. So here I'm going to try to draw the problem out. This would be the winch, and it'll be mass m. We'll do a capital M to differentiate. And then here we have the bucket, and the bucket will be a small m, which is what we're trying to solve for. And this overall is the general height of the well. And then we have the water down here. So let's try to do a free body analysis of each of the objects. So for the winch, the forces acting upon it are gravity. So we have the mass times gravity, its own weight is pulling it downwards. Then since it's a circular object and it's turning, it has the radius right here, radius r, capital R, and the torque, which is also a force that's pulling it downwards. And then we have a force that's pulling it upwards. And then we have here the x direction, just the general x direction force. And then for the bucket here is being pulled downwards by its own weight as well. And then it's feeling in the y direction to pull downwards. It also has the x. And then it's actually being pulled upwards by the torque in this case. And by tension. In this case, it's tension for the bucket. So the equation for the bucket is going to be that the sum of the forces in the y direction is the weight minus the tension. And that would be equal to m times a in the y direction. And then for the winch, to find the sum of the tension, we would have to find the inertia times the angular acceleration. So tension times the radius will be equal to half of the capital mass times r squared times the angular acceleration. And then if we cut out the r's, so they can be both divided by r, we would have half of ma in the y direction. So now let's continue solving this because I'm running out of space. Okay, so we're left with the tension is equal to half of the mass of the winch times the acceleration in the y direction. And then from here we can continue to move things around, and we would have the weight minus half of the mass times the acceleration in the y direction, and this will be equal to the mass of the bucket times the acceleration in the y direction. So we're trying to find the correlation between both of these objects. Then here the weight would be equal to the mass of the bucket times the acceleration in the y direction plus half of the mass of the winch and acceleration in the y direction. And then we continue to simplify this. It'll ultimately bring us the mass is now plus half after we factor out these m's, and it will be plus half m times the acceleration in the y direction, which is what we're ultimately trying to find. And then once we solve all of that, we know that the acceleration in the y direction is the weight over the mass of the bucket plus half of the mass of the winch. And then we can multiply both of these sides over 1 over m over 1 over m. Now let's continue. So now that we know that the acceleration in the y direction is equal to what I previously put, the weight over the bucket's mass plus half of the winch's mass. And now we multiplied by 1 over m over 1 over m. This would leave us with the force of gravity over 1 plus the mass of the winch over 2 of the mass of the bucket. And that would be our acceleration in the y direction. And now, if we keep going, we know that acceleration in the y direction is equal to the radius of the winch times the angular acceleration. And we know that the angular acceleration is equal to 1 over the radius of the winch times the acceleration in the y direction. So once we plug these values in, we know that the angular acceleration is gravity over, let me put this down, gravity over the radius of the winch over 1 plus the mass of the winch over 2 times the mass of the bucket. And that is our overall angular acceleration.